We are given that the bacteria population obeys the population growth law. So, using this information, we can write down the population model, that is P of t equals P naught e raised to the power of kt. This P naught is the population of bacteria after time t. This represents population after time t. This P naught is the original population. This K represents the growth rate, and T is the time in hours. So we'll be using this population model to answer this question, that is to determine the time T when the population increased to 7 times of the original population. We are also given that the doubling time of the bacteria is 4 hours. So let's utilize this information. We can convert this mathematically. That is, when t equals 4 hours, that is when t equal to 4, the population gets double. So we can say that p of t equals 2 times of p naught. So this is the mathematical equivalent of this statement. Now, using this mathematical equivalent, we can plug it into the population model to determine the value of k. So I'm going to do that. Let me copy the population model here. That is p of t equals p naught e raised to the power of kt. Now let's plug in t equal to 4 and p of t equals 2 p naught. So this p of t, this will become, when you plug in t equal to 4, this becomes p of 4, and this equals p naught e raised to the power of k times of t equals 4. So p of 4, when you plug in t equal to 4, this will be 2 p naught. That is, this implies we can write down for p of 4, because we plug in t equal to 4 into this expression. So therefore, this equals 2 p naught. So I'm going to replace p4 by 2 p naught, and this equals p naught e raised to the power of 4k. Now we can divide both sides by p naught. So this p naught gets cancelled. So we will have 2 equals e raised to the power of 4k. Now let's apply natural logarithm to both sides. So when you do that, we get natural logarithm of 2, and this equals natural logarithm of e raised to the power of 4k. We know that we can apply the power property of natural logarithm, and when we do that, this 4k comes in front. So I can rewrite this equation as natural logarithm of 2, and this equals 4k times of natural logarithm of e. Remember that natural logarithm of e, this equals 1. And this means I can replace this as 1. So 4k times of 1 is 4k. So I'm going to remove this from this equation. So we now have only natural logarithm of 2 equals 4k. So this means we solve for k by dividing both sides by 4. So we get the expression for k equals natural logarithm of 2 over 4. So this is the expression for the k. Now let's substitute this value of k into our population model. So we can rewrite the population model. We have a population model, that is p of t equals p naught e raised to the power of kt. So I'm going to replace k as a natural logarithm of 2 divided by 4 times of t. So this is the population model which we can utilize. We now determine the time t so that the population increased to 7 times the original population. So let's convert this to mathematical equivalent. So this equals, we have to determine time t when the population becomes 7 times the original population. That is, we can write down this as p of t equals 7 times the original population. Original population is p naught. So p of t equals 7 times of p naught. And when this becomes, we have to find the corresponding t. So I'm going to substitute p of t equal to 7 times of p naught into the population equation. So let me do that. I'm going to replace P of t, which is 7 times of P naught, and this equals P naught e, yeah, it is e raised to the power of natural logarithm of 2 over 4 times t. Now we divide both sides by p naught, so this p naught get cancelled. So this implies we will have 7 equals e raised to the power of natural logarithm of 2 over 4 times t. Once again, we apply natural logarithm to both sides so that we can solve for t from this equation. So we have a natural logarithm of 7 equals natural logarithm of e raised to the power of natural logarithm of 2 over 4 times t. Now we use the power rule of natural logarithm. This means this power of e will come in front. So we can rewrite this as natural logarithm of 7. This equals natural logarithm of 2 over 4 times t. And then this multiplied with natural logarithm of e. We know that natural logarithm of e equals 1. So I can replace this by quantity 1. And this means I can just, I'm sorry about it. I can just remove this from the equation. So I'm just removing this. So now we can solve from this equation. We have to solve for t. To solve for t, we have to multiply both sides by 4. So therefore, this becomes 4 times of natural logarithm of 7. And then we have to divide by natural logarithm of 2. So let's do that. So 4 times of natural logarithm of 7 divided by natural logarithm of 2, and this equals t. So therefore, the expression for t, or we have determined the t as 4 times of natural logarithm of 7 over natural logarithm of 2. Therefore, answer choice A is correct.